Welcome. Welcome to another episode of The Impact of AI, sponsored by AI Time Journal. Every week, we explore how AI and cognitive technologies impact us daily, both professionally and personally. For those of you whom I've not met yet, my name is Melissa Drew, and I will be your host for this week's podcast. This week is going to be quite intriguing. We are lucky today to have Chief Technology Officer Blair Newman. He is the Chief Technology Officer of Neuton, Neuton.ai on the website. Now, Neuton is really interesting. For those of you who are data scientists and machine learning and chief analytics officers, Neuton software and patented application allows you to make these predictions, leverage your automated machine learning without any code. Yes, that's what I said, without any code. So we are definitely going to explore that in much more detail today. Welcome.
Thank you for having me.
First question, always the same. No one's story is a direct path from where they started to where they ended up. And in looking at your LinkedIn, you started with very technology behind the scenes. I think I saw the word mainframe somewhere in there. And now you're the Chief Technology Officer of a patented company. I know there's a story there. I'd love to hear it.
Yeah. So again, I'll just start off by thank you, Melissa, for having me. And maybe I'll probably date myself since you've already mentioned mainframe. But actually, when I began my career, I wanted to be a truck driver.
No, I love that. I love that.
Yeah, I always wanted to be a truck driver. And I think in the end, I did have the opportunity to live vicariously through a truck driver, except that I wasn't driving a truck. I was actually on a plane. So I think, my mom always have told me that I'm still a truck driver. I just replaced 18 wheels with an airplane. But my career, I actually just stumbled upon technology as a whole, where it was a little bit more or less as a challenge. I originally started in robotics, and I invested a tremendous amount of time in learning how to develop code that ultimately would cause an object to move. And when I completed this particular course and this project, I spent a tremendous amount of time, and then it moved like 6 inches. And I was like, I did all of this work to move 6 inches. And I was so frustrated, and then I gave up on technology. And I was like, this is a lot of work for very little output. But then it was brought back to me via, I would say a little bit of a challenge as it relates to one of my dearest friends when he began to introduce to me. At the time, it was Unix. Mm-hmm. And they had mentioned how challenging, how intriguing, and also the capabilities that existed in this platform. And that's what really kind of launched my technical career. And from there, I not only began exploring how things could function in that world, which of course was the backbone of what we call the internet now. Mm-hmm. But then that drove me into a number of other different areas. And one of the things that I really loved, and which also intrigued me, was seeing the light bulb go off. And what I mean by the light bulb is the realization of a possibility. And as I continued throughout my career, starting not first, but I would say at Sun Microsystems, which is now Oracle, Verizon Business, and even now up into including where I'm at with Neuton, is I've always really just truly enjoyed being able to not only implement solutions, but also to provide solutions that allow for the light bulb to go off. Mm-hmm. And in the case with Neuton, that's where we kind of ended up. We have historically been a systems integrator. And being a systems integrator, we work with a number of different organizations who are, let's say, looking to solve business problems, some a little bit more innovative than others. And in doing so, we were, you might say, working in the AI space a little bit more traditionally, but also helping them to integrate these solutions into their ecosystem. And what we found is that it was laborious, not only on our side, but also on the customer side as well. And we began to say, hey, how can we challenge the status quo, not only internally, but also externally? How can we, and from my perspective, flip another switch and make the light bulb go off? Mm-hmm. So we decided, hey, my mission was twofold. How can I bring this type of technology and innovation to the fingertips of our customers? And how can I literally enable AI or machine learning for everyone? And that was the impetus of Neuton. And that's where we began this journey of producing an AutoML solution that truly enables machine learning for really every demographic. So a little bit long-winded, but that's my story. I'm a truck driver and I'm sticking with it.
I love it. I love it. I love that one. I think I'm probably somewhere in your age group. So I went to college in 1997, 98. I did start out in computer engineering until they told me I had to start learning mainframe programming, and similar to your experience, didn't like it. And then I shifted over and did information systems and technology, which I think is where you ended up as well. Yeah.
Yeah, absolutely.
Yeah, it allowed me to get what I wanted to do faster instead of the mainframe programming. Very similar experience. Oh, that's funny. I love it. I want to go and really understand more about your company. A little bit maybe more on since you are the Chief Technology Officer, we're going to have such a unique perspective because your role, you oversee the strategy, the execution. I mean, everything is umbrellaed under to you. So a little bit more about Neuton, because I think that's the name of the application, Neuton AutoML. What does it do? Why is it? You've mentioned no code. Maybe give us an example of a real world case scenario.
Yeah, absolutely. Yeah. So one of the things that I mentioned, as an organization, we've been around for a little over 17 years. Sometimes, or at least historically, some of our customers are a little bit more familiar with us in regards to Bell Integrator, where we've historically been a systems integrator. I always like to mention that for a couple of reasons, which I'll touch on in a moment. But we began really roughly over, I would say about 6 or 7 years ago. Really, you might even say we kind of went through our own digital transformation. And we really embraced one of the comments that I mentioned earlier is how can we bring services to the fingertips of our customers? And that started us on this journey of building a number of different solutions that enabled and brought to life this idea of having services at the fingertips of our customers. And this included augmented reality solutions. It included some IoT solutions, up into including Neuton, which we're here to really kind of focus on and discuss today, which is a solution that really truly brings machine learning to the fingertips of our customers. Now, how do we do that? So we start off with really the basis of enabling every demographic. So when you begin to kind of highlight some of our differentiators, number one is, I don't like to use the term, let's say easy, but we wanted to develop a platform that was simple, that was very intuitive. So one of the hallmarks of our platform is that we have a 3-step workflow where our customers truly in 3 steps can produce a predictive model. It's extremely important for us when it comes to usability. But usability is one component, but our overarching desire is how do we take our customers through the entire life cycle of being able to not only produce a model, but also implement that model into their ecosystem. Because to me, producing a model that you can't implement it into your ecosystem, I like to call it a shiny object. And that's where I mentioned, our background as it relates to being into systems integration, we're able, when we're capable of implementing that entire life cycle. So now when we kind of hone in into machine learning, so number one of the most key and principal components of machine learning is being able to make sure that you have the data that is required in order to actually produce a predictive model, right? There's that old adage of junk in and junk out. Mm-hmm. So we help our customers as it relates to data preparation, understanding their use case so that they can in turn be able to take advantage of our platform. So when they begin to enter our workflow, going through those three various steps, we take our customers very quickly as it relates to automating everything, to uploading their data set, identifying their target variable, and then completing training. So our customers, they don't have to invest anything from a technical perspective to understand those steps. And we assist them as it relates to data pre-processing. And in that case, it means if you have missing data, which is inevitable, you need to convert your data into machine readable format, which is normal for irrespective of any platform that you may use, as well as what we call feature engineering, or typically the industry calls feature engineering, where we begin to analyze your data, extract that data, identify the connections between that data so that we can ensure that we help you produce a model that is as accurate as possible. So as we kind of now continue through that life cycle, we provide a tool. We have an extremely robust, what we call explainability office that provides our customers insight to their data prior to training, prior to producing a model. Then once a customer then produces that model, and again, we're automating all of this, we provide what we call a feature importance matrix, which gives our customers and identifies to our customers what are the top 10 features, our data points that are producing the predictions that will ultimately give your organization value. And then there's the converse to that side, which is extremely important. What are the bottom 10 features, right? Because sometimes our customers, if they're looking to do churn prevention, they're looking to understand customer lifetime value, they're looking to understand what's the next best product. Sometimes they may come into the discussion with the belief that there are certain features in their environment, in their ecosystem, that are influencing predictions, which in reality they're not. So we show the top 10 as well as the bottom 10. But more importantly, the next thing that we provide is we provide complete transparency to our customers as it relates to what's driving those predictions. Historically in this field, and this is one of the key, I would say, technical aspects that we've addressed, is the transparency and as it relates to predictive models, specifically neural networks. Mm-hmm. This has been kind of the boogeyman historically, is, hey, I want to do predictions. Hey, I want to do machine learning. But the question has always been, well, what's behind those predictions? Can I trust those predictions, right? And that's one of the areas that we also address, is we give our customers just a tremendous amount of transparency as to what's driving predictions. Now, what does that mean? That means that we allow for our customers, and this is something that is forward-leaning, very innovative, and that our customers can dynamically change the value of any feature to see how it may influence a prediction. So you know exactly why your models are making the predictions that they are. So if you need to identify if your model has any bias, if you need to go through and identify, a specific customer profile, our platform does this automatically. And that's something that, once again, we enable our customers to do without needing to understand, the back-end technology behind that. And then I'm sure you've probably yourself, and maybe our audience, has heard a little bit more about edge computing, a little bit more about TinyML. And this is the other area where, just quite frankly and humbly, we're just exceptional at. One of the things that we have focused on, and I'm not afraid to say we actually stumbled upon this. So when we looked at some of the limitations we would experience with other frameworks, whether it was TensorFlow, PyTorch, is not only would it typically require a significant amount of data, but we just found that the approach was inefficient because you would typically start out with an existing structure. Oftentimes that structure consisted of a structure that you didn't entirely need to use. So there was a lot of waste. And that's typically what I like to call, it was a top-down approach. You start off with an existing structure and then you build your models from there. And we challenged the team to say, hey, how can we do it different? Because innovation is driven by disruption. So we take a completely different approach. We build all of our models, neuron by neuron, step by step. And in doing so, one of the benefits that we've realized is that not only are our models extremely accurate, because we're performing cross-validation along the way, but they're extremely compact. So we've also found that we've had the opportunity really to be right in the middle of the next evolution of machine learning as it relates to tiny ML. And you hear about edge devices and the intelligence that we find everywhere. So this is another area that we've been extremely fortunate enough to really be making a difference, I would say, as it relates to driving the adoption of machine learning. And that's our story, and I'm sticking with it, Melissa.
That's great. That's great. I want to go back to what you said. You kind of stumbled into this. Did you stumble into the business itself? Like, what prompted you from moving out of the previous role you had to suddenly starting the company? Was it just recognizing what you think this technology should have been, you weren't finding it?
Yeah, thank you. So you give me an opportunity to kind of, let's say, clarify. So as a systems integrator or service provider, we were working with a number of our customers as they were looking to explore various machine learning projects. One of them that we were working on, as an example, is we were working with a retail company, and they came to us and they said, hey, we want to develop a mobile application that allowed for our customers to begin to explore their products outside of their brick and mortar location. And it was an automotive retail company. And they said, hey, we want our customers to take their mobile phone, take a picture of their car, and automatically identify the vehicle and then map the accessories to this vehicle.
I like that.
Now, on the surface, for our customer, it was a typical e-commerce engagement. But in reality, we were using machine learning to identify the vehicle, and we were using an additional technology around augmented reality so that the customer can visualize those accessories on the vehicle. And then, of course, if the customer was interested, we would then take them into the process of purchasing those particular items. Now, we were able to accomplish this task and implement this project, but in reality, it was a fairly extended engagement. And when we began to think about it, not only for ourselves, but for our customer, the time to market was extremely long for our customers. And the reality, it was very laborsome, not only for us, but also for the customer. And there's only so many data scientists that are in the market, right? Even though we have a fairly robust organization ourselves, it was fairly labor intensive. And we said, hey, how can we just do this more efficiently? And so we decided to kind of build on our lessons learned to, working on traditional machine learning projects, using traditional machine learning techniques, and then begin to say, hey, how can we do this more efficiently? And that's what drove us to producing an AutoML solution called Neuton, because now we were addressing a lot of those various challenges that we had previously experienced. So that is what kind of drove us to the solution of Neuton. When I say that we kind of stumbled upon things, I mean this explicitly from a tiny ML perspective. The approach that we were taking in building models, we realized, oh my gosh, we're building models that are extremely compact, that as soon as they're built, they're able to be integrated into a microcontroller. Whereas when you look at some of the other tools and techniques that are out there, when you build a model, you just can't immediately just integrate it. You have to take a number of different steps, and it's very laborsome, and oftentimes you compromise accuracy in doing so. What we found what I mean we're stumbled across is that the algorithm that we developed, that we've subsequently patented,
Mhm.
that resulting model our customers can integrate instantly as soon as it's produced out of the box with our platform. So that's the aspect that to some degree we stumbled across, because 4 years ago, I mean, TinyML, it's still in its infancy stage,
Mhm.
but it wasn't driving the adoption that we're seeing today. And so based upon that, that's where I mean where we've been able to stumble across things.
Mhm. I definitely want to talk more about the scalability aspect of it. But before we do that, I went on your website, I saw some of your demos, I got to see, how your product works. But for the purposes of our audience here, can you give us a real world example, maybe one of the clients that you've worked with before, so they can visualize what it is that we're talking about?
Yeah, absolutely. So I think there's two aspects that maybe I can just briefly highlight. Now, I like to say, there are some use cases from a TinyML perspective, and there are some use cases, let's say, from a traditional machine learning perspective.
Mhm.
So let's just say a traditional machine learning perspective, we have the opportunity to work quite a bit in, let's say, in the educational space, where we're enabling some of the, new engineers that are out there. And then we also work fairly extensively in the financial services space, or with credit unions, as an example. And with credit unions, some of the challenges, let's say, that, that they face, is a little bit different. They're a little bit more community based. They're receiving some pressures from the larger financial institutions. They're receiving some pressures for fintechs. So, their ability to go out and identify, new customers, new demographics, let's say millennials who may have a thin client profile, right? That means they need to begin to take into consideration different features as it relates to millennials than you might find for someone like myself, who's been around a little bit longer, who has a very established credit history. So how do we help, a credit union go out and identify and understand either the risk or the opportunity with a potential member who may not have as thick of a credit file as myself?
Mhm.
And then in addition to that, we also help them understand the risk around their existing customer base. So one use case, and I like to typically talk about this use case because it spawns different opportunities that credit unions can take advantage of, where we risk rate all of their members, whether they're new or existing,
Mhm.
without the FICO score. So just based upon individual member attributes. And then from there, we help them to understand, based upon that risk rating, what is the most likely product that you're likely to consume.
Huh.
Um, in addition to that, if we can help you and we can identify where you're at in this risk rating model, what's your roadmap that you should take in order to, let's say, if you're higher risk, to, let's say, lower that risk and then grow and then move into a growth opportunity. And if you're lower risk, how can we move you into a growth opportunity? Whether it is taking a customer from that may be, let's say, have just a standard banking account, standard savings account, and then moving into a growth opportunity, not only for the customer, but also for the financial institution. And this is an area where we found that credit unions, as an example, especially really during the pandemic, because now everyone is looking for, they're forced to look at different opportunities as to how they engage customers, how they engage us, because we're not going into the branches anymore, right? Not as often as we used to.
Yeah.
And so the touch points that you need to have with your community is significantly different. And how you identify and assess those potential members or existing members are now completely different. Right now, you need your engagement, let's say from a mobile phone or from a smart device, it needs to be much more rich than what it's historically been. And so this is an area that we have found more recently where we're able to help customers build a model literally within days, implement those models and begin to kind of realize those benefits, whether it's an aversion benefit of a customer that's at risk for defaulting, or whether it's an opportunity for growth for customers.
Mm-hmm. A lot of times when I hear people talk about tiny ML or very compact models, there's this myth or this misconception that I can only use a small data set to make a very controlled decision, but it's not something that's really going to help me with my larger data sets. Can you help clarify that myth?
Yeah. So if you allow me, I'll maybe kind of categorize it a bit different.
Yeah.
I mean, in one of the earlier points in our discussion, I was telling you about how we were working with, an automotive retail organization that was looking to identify some vehicles. We were chartered at that time to just only identify vehicles going 10 years back.
Right.
And in order to do that, we might have needed in excess of over 6 million data points to be able to produce that solution. It's a significant amount of data.
Yeah.
And our solution was able to reduce that data requirement once we developed Neuton by over 80%.
Wow.
Right?
Wow.
So let's say that was kind of like our initial leap. And
right.
Now when you begin to talk about, let's say, TinyML produces a little bit of a different, unique challenge in that the data that you're receiving is largely limited to the sensors that particular device can digest. So if you're, let's say, taking images of a given environment to identify, let's say, if a particular animal walked by, if you're reading, let's say, the gases that a particular fruit or vegetable may emit, so you can try to predict the spoilage, right? So, and that data can oftentimes be inconsistent, right? So you may, some days or some moments or whenever you take those readings, you may receive everything. Sometimes you may not. And that's one of the areas where we also really kind of excel, is that specifically in the TinyML space, sometimes you may be in a position to receive a material or significant amount of data or inputs, and sometimes you may not be. And that's one of the areas where we have tended to excel, is that our solution and our models can take in that data, even if it's incomplete, even if it doesn't consist of all of the data that historically, leveraging other technologies, other platforms, you will require to use, right? And this is the opportunity with TinyML, right? Is we have these small devices, and yes, they're becoming more efficient, more compact, but a lot of times the input into these sensors are not, they don't contain as much data as we need or we would like. But this is one of the areas that we're able to address fairly efficiently.
And to connect the dots, this is where your patented predictive model comes into play. Now, I'm glad you articulated that, because it connected a lot of dots for me, and hopefully everyone else listening. We oftentimes hear, if I want to make a really good model, if I want to ensure that I can trust the results, I need to make sure I'm pulling in a comprehensive data set, which oftentimes means a large data set. I interviewed someone recently, a couple of weeks ago, that said at this point in time, they are collecting over 130,000 different data sets in order to make a better informed and trusted decision. So I think what I've heard from you is that there's alternative ways to make those decisions, and utilizing Neuton, this application with this patented technology, applies that predictive component on it, because we're never going to always get 100% of the data we need.
Yeah, I mean, I love this question, quite honestly. We had the opportunity to, at least myself, I had the opportunity to speak at a TinyML summit. And this was kind of, you might say, a second coming out party for us, because we began to divulge more as it relates to our approach to building models that are materially different than maybe what you have previously heard. Mm-hmm. And we do this in really two very distinct ways. Number one is when you look at all of the features that you may have available in these very large data sets. What we do is, as a part of our algorithm, we take a very selective approach of only connecting to features or data points that have the highest predictive power. And then in addition to that, one of the key features of our algorithm is we have a very robust generalization capability, mm-hmm. which means that, our models, our algorithms is able to understand very efficiently data that it may not have seen. Mm-hmm. So not oftentimes, our models are self-learning and they're self-growing. So initially we're starting out with very selective features, which contributes to our models being very compact. And because our algorithm has a very robust generalization capability, we're able to we're able to process features and information that we hadn't before, and then apply that, and then make still very effective and accurate decisions as it relates to the predictions that we're taking to place. Mm-hmm. When you look at other approaches and algorithms, they are restricted to needing to know as much information as possible, where our algorithm is taking a bit of a different approach.
Right.
We start off extremely small, and then we learn along the way, and then if necessary, we'll expand.
There was a survey done on LinkedIn recently about what's holding you back from building out this area, the data infrastructure, the analytics, the skill sets, the data scientists. And the number one feedback on that survey was the cost for the infrastructure, the cost to go hire people. Where are we going to store all the data? Do we need a data fabric? How many systems are we? I mean, there was just it was the number one was cost. But what I'm hearing from you is that this is a way, you and what you've developed, this is a way to really get ramped up more quickly and start getting some of those return on investment and getting some results, maybe in parallel while you're trying to build out a much larger, infrastructure. Is that accurate?
Yeah, absolutely. I think when you talk about the capital that's required in order to produce models, and I think you described it perfectly. Capital could mean, people, expertise. It can mean infrastructure. I mean, you name it. When you begin to talk about the capital that's required, the capital is immense. Mm-hmm. But when you also begin to talk about what is the opportunity for machine learning or tiny ML to really grow exponentially, you look at the demographic in the tiny ML community. The data scientist is respectfully probably the minority, right? And the majority of this community is probably the software developers, the embedded engineers. Mm-hmm. And here's an analogy that I like to use, and it's just my analogy. I need to drive a car. I mean, at least where I'm at, I need to drive it, right? Yeah. But Melissa, I don't want to be a mechanic. I just want to drive a car to get me from point A to point B so I can achieve a specific objective. And when you look at the majority of the people who are in the space that really are an opportunity to drive the growth exponentially from a tiny ML perspective, those embedded engineers, they know or they believe, hey, I really want, intelligence on my device, but I don't necessarily want to be a mechanic. I need the result, but I don't want to know how to build an engine. And for us, this is where we're raising our hand and we're saying, hey, from a Neuton perspective, from an auto ML perspective, we can enable you to get from point A to point Z. But again, you don't necessarily need to be a mechanic, but we can help you achieve your overall business goals. And we need mechanics. Don't get me wrong. When my car breaks down, I'm gonna be the first one at the car dealership to say, "Hey, can you please fix my car. But for the masses, we don't need that. And to enable TinyML to grow exponentially, this is where, for me, I truly believe that this is where we're playing a huge part. And if you look at my virtual background, we say build fast, build once, and not compromise, right? So that's time to market. How can we empower that embedded engineer to accelerate their time to market? And when we talk about build once, that's a part of our patented technology, that you only build a model in one iteration and you can implement it immediately and not compromising as you have business requirements where you need to understand what you're doing and you want to be able to deliver value to your customers. And that kind of, let's say, is the overlay that we also provide from a service perspective. So when we talk about, the democratization of AI and machine learning, so this is the mantra that we're following to play our part.
Yeah. I mentioned earlier, I wanted to talk about scale and scaling, and I want to fold that in at this point. Another piece of feedback that we typically get, or I typically get, is I've spent 3 years building that infrastructure. I've got it. I've done my first proof of concept or my first pilot. And what's holding us back, and specifically statistics have proven that in manufacturing, we're fourth in line of manufacturing compared to the rest of the world, because we're getting stuck in the proof of concept phase. We're not able to pull that into a production environment and scale those models so that we can start using it in other areas. So I'd like to understand a little bit more about how you can help solve that, because I'm sensing that you can, from everything I've heard, and it's such a huge tactical discussion at the moment. But I think you have a solution for that.
Yeah, I think so.
Yeah.
And I'll share with you one of the things I like to always kind of joke about. Obviously there's other choices besides Neuton, and I'm very fond of one of our competitors. They have a ticker on their website about how many models have been produced.
Okay.
And it always reminds me, honestly, of the Cinco de Mayo counter, right? It's kind of like, oh, we're counting every time, we're getting there, right? It's inevitable, we will get there, right? But then when you kind of take that next step and you say, well, how many has been implemented into production? Right?
Yes.
Then that number kind of, it drops drastically. And this is what I call the shiny object syndrome, right? Where, you have an opportunity where you produce a model and then you say, then what? What do I do next? And one of the things that we do is we enable all of our customers that engage with us. We ensure their success from build to implementation. We take them all the way through the entire life cycle, because in the end, if they don't realize the value that machine learning can bring their organization, then they'll just end up being just another shiny object of producing a model. And they say, well, what do I do with this data? I have it. And this is where kind of our background, this is where our DNA of being involved with systems integration and being involved with understanding what does it take to then actually implement a solution that ends up at the fingertips of their customers so that they can receive the value. And that's something that we do. So we assist our customers, whether they're using our free plan, whether they're using one of our commercial plans, to go through that entire life cycle of implementation, not just building a model, but of implementation, because then that is ultimately what will drive sustainability, is producing the model, implementing the model, realizing the value of that model. And we do that because that's where we believe that then, when you build that relationship, you ensure that success, then you have, acceptance and, satisfaction on both sides.
How, looking at the teams, we haven't even talked about how wonderful your team is, because they must be a wonderful team. How big of a team do you have behind that's helping you, create all this?
Yeah. So, it's been one of my personal mantras. I had the opportunity to teach some time ago. And when I would engage some of my students, I would say, at the end of the class, I don't want to be the smartest person in the room. And
Wow.
when you look at our team, so we have as organizationally, we have a little over 2,000 employees, but that's really dedicated to Neuton, which we're focused on today, is roughly around 50 to 60 professionals, both technically as well as, non-technical resources that are really geared towards this particular effort, right? This, and we have an exceptional team of data scientists. And, one of the key attributes of a data scientist is actually not their technical skills, right? They need to be able to understand the business. That's what really separates the data scientist, right? Is you need to be able to understand and know that tribal knowledge and understand what the customer is really trying to solve. Because when we're speaking with some of our customers, more often than not, they're not saying they need a machine learning solution.
Right.
They're saying, hey, I want to drive more efficiency in my branch office. I want to understand the lifetime value of my member. I want to understand which of my customers are at risk. I want to understand if, what's going to be, the graduation rate of my students. They're not always saying, I need machine learning. And it's imperative that we have an organization that can communicate to the customer based upon what their needs are, and then ultimately translate this into how Neuton provides value in that particular area based upon their challenges that they're experiencing. And this is one of the areas that I'm always extremely happy to say that, we have an exceptional organization that is capable of doing this. And more often than not, I am not the smartest person in the room. And that is my measurement of success.
That's brilliant. Well, unfortunately, our time is coming to an end. So we will wrap up with the last question. For those listening who want to follow in your footsteps, do you have any lessons learned, any advice that you can pass along?
Yeah, absolutely. For me, and I've shared a little bit about my journey, and I'll share a little bit more personally. I've had the opportunity. I have two young men that's been in my life, two of my sons, and they're at different points of their lives. One is about to leave college, and one is about to enter college. And in our discussions, and I've had this discussion with both of them, and they've asked me, Dad, what do you think I should do? And one of the things that I tell them is I say that I haven't worked in 25 years. And they always ask, what does that mean? Right?
Yeah.
And for me, what I do today and what I've done throughout the course of my career is been fueled by passion. It's been fueled by truly something that I enjoy. So if you ask me the question of what feedback would I have for anyone, and I would get feedback, whether it's, in this specific field or if it's just in life, I would just say, identify, find, pursue, and live your passion. And that will take you to all of your points in life that you will desire. And that's how I got to where I'm at. I got to where I'm at because this has just always fundamentally been a passion to be able to have the opportunity to realize when a light bulb goes off in whomever I'm communicating with. And hopefully, as a part of this audience, I've been able to turn on a few light bulbs.
Well, that response is simple but powerful. Thank you. And thank you again for setting time out today and chatting.
Thank you.